In this next set of examples, we're going to write each expression. Now I've got two trigonometric expressions here. We're going to write each expression in terms of sine and cosine and simplify completely. Okay. Now your book and my math lab will word that a little bit differently. Instead of simplify completely, I just kind of simplified it, shorthanded that. The book here, as I see it, says simplify the expression so that no quotients appear, so we're trying to get rid of fractions, and all functions are of theta only. So we don't want any like negative theta. So like sometimes there'll be sine of negative theta and you want to get rid of the negative somehow. So those are the things that we're going to be interested in doing here. Okay. So I just said simplify completely because I don't want to write all that out. Anyway, so these are two different problems. So I'm gonna start on the left one here and work through these. First of all, we write everything in terms of sine and cosine. That's going to be very common to do because sine and cosine, everything can be sort of boiled down into sine and cosine. Your tangent is sine over cosine, your cotangent is cosine over sine. The other ones are reciprocals of sine and cosine. And so if you can write everything in terms of sine and cosine, it just gets them into a, more manageable functions, things that we can work with, and gets everything down to two different functions. So we'll start there. So the cosecant we know is the reciprocal of the sine. So I would write that as 1 over the sine of theta. The cosine, well, it's already cosine, right? I don't have to do anything with that. And the tangent we know is the sine over the cosine, right? So that's sine theta over the cosine of theta. Well, I'm going to simplify. I really have three fractions here. And I can cancel any common factors. I've got a sine of theta on top and a sine of theta on the bottom. I could cancel those out. I also have a cosine of theta on top and one on the bottom. I could cancel those out. Interestingly, I've canceled everything out except the 1. There's always a 1, right? Answer is 1. That's a simplified form. So if you multiply cosecant times cosine times tangent, the product will equal 1. It's kind of interesting. I like that one. Let's move over to the other one here. The cotangent squared times 1 plus tangent squared. Well, the cotangent squared, if I write that in terms of sine and cosine, it's going to be cosine squared over sine squared, right? Because cotangent is cosine over sine. So this is cosine squared over the sine squared, right? So if you square a fraction, the square splits up. 1 plus the tangent squared can be simplified using a Pythagorean identity, right? 1 plus tangent squared is the secant squared. That's a Pythagorean identity. Okay, so I'm just making a replacement. One thing that's actually useful here, and I neglected to do it on the first one, is to write in what properties were used, just as a way of keeping track of your work. Here I might say quotient and Pythagorean identities. Okay, so just kind of writing out what was used. Here I might say a reciprocal and a quotient identity, and then just canceling or something, simplifying. Okay, from here I know that the secant, I got to get these in terms of sine and cosine, right? The secant is 1 over the cosine. So this becomes the cosine squared times the sine squared, or over the sine squared, sorry. And then times 1 over the cosine squared, that's our secant. The two cosine squareds cancel out, one on top, one on the bottom. So that's using a reciprocal identity. Cancel a little bit there, I get 1 over the sine squared. So that's, what would I say there? Cancel common factors. Okay. And then I want to simplify this completely so that there's no fraction involved. 1 over the sine squared, we know the reciprocal of the sine is the cosecant. And so this ends up being the cosecant squared, CSC squared theta, right? So that's using a reciprocal identity again. Okay? And then that's as far as we can go. That's a simplified form. So the cosecant squared is equivalent to the cotangent squared times 1 plus the tangent squared. Okay? So essentially what we're doing is we're trying to equate 2 different trig expressions, right? The top trig expression and the bottom one are equal to each other, right? Using these steps, using these fundamental identities. Same thing here, the top and the bottom are equal to each other, all right? So we're trying to create new identities, essentially. This is an identity, one trig expression equal to another one, using the fundamental identities.